Now we're going to talk about circuits. So we have a circuit diagram here, and we have 3 loops. And some of the loops share a wire, and we have batteries and resistors. So there's no capacitors on these. We're going to use a couple of properties here. One is that resistance times current is going to equal voltage. And we're going to use the fact that voltage can't be created or destroyed inside of the circuit. So in this first loop, there's 30 volts being supplied by this battery. And when we write up our equation, whatever we get, the other side's got to equal 30 volts. So we're going to have an equation for each loop, and I'll just give them the names of their currents. And then the first loop, we've got 3 resistors, and all together, they're all getting multiplied by this current. And together we have 4 plus 3 plus 4. That's 11 ohms times the current, say I1. And it's also sharing this resistor with the second loop. So this resistor is also, we're going to multiply this by the second loop as well. And if you can see the direction of these loops, this one's going this direction and this one's going in the opposite direction. So since they're going in opposite directions, we're going to use a negative sign on this resistor being multiplied by I2. So we're going to say minus 3 I2. And there's not an I3 or I4. We stop at I3, but it's not sharing one with I3. So we'll just say this is equal to 30 volts because that's our battery. All right, so let's do the second loop. I'm going to add up all the resistors. So 3, 4, 5, 6 in the loop. So that's 6 I2. Remember, that's voltage, right? The current times the resistor or the resistance equals the voltage. But it's sharing 3 from I1, so we're going to subtract 3 I1 because they're going in the opposite directions. It's also sharing this guy with I3, so we're going to subtract 1 times I3. And we're going to look at our battery. So it's 5 volts, and you want to check to see what direction the loop is going through the battery. So you see we got this short side and long side here, and we're going this direction through that battery. So we called that positive 30. This loop is going this way, so we're going from small side to larger side. These are actually plates, but whatever. You might even give one side a positive sign, one side a negative sign, but we're going the same direction through this battery, so we'll also use 5 volts. Or positive 5 volts. All right, last loop, I3 loop. I'm going to add up all the resistors. 1, 2, 3. It's 3 I3. And I've got one shared resistor for I2, so I'm going to subtract 1 I2. And this loop has 2 batteries. So one is going this way through this battery in the opposite direction that the other loop, the second loop's going this way. This loop's going the opposite way. So this is going to be, we're actually going to use negative voltage here. That just gives you a direction, right? The negative sign. And we're going the same way through the other battery we're looping this way. This is counterclockwise. And we're going from the big plate to the little plate, or the long plate to the short plate. And here we were going short plate to long plate when we were going this direction. So in total, we have two batteries here. We're going to say they're both negative. They're both negative, so a total of negative 25 volts. So we're going to set up a system where our variables are the currents, and we have a column for the battery, or the voltage. This will be 35 and negative 25. And in the first equation, we have 11I1, negative 3I2, 0I3. Second equation, negative 3, 6, negative 1. Third equation, 0, negative 1, and 3. So to solve this, we just need to use a calculator. So when I use a calculator, I get this reduced matrix. So current I1 is equal to 3. I2 is equal to 1. I3 is negative 8 because of the direction. I think this is in amps. You can correct me if I'm wrong. But there we go. There's our current. So you're going to have, and let's go over this again. We're going to have an equation for each loop. You're going to add up all the currents and multiply them, or add up all the resistors and multiply it by each current, and some of them will be shared. And when they share one, they're usually opposite signs. And you have to keep track of the voltage supply of the battery, what direction is the loop going through the battery, and make sure that we use a consistent system there. We could have called these two negative and this one positive, and it would have been fine. It's just the direction is being dictated by the negative sign.